Because we really didn't expect so many people. I think we can begin. You are very uncomfortable. And we may begin. This is like a relaxed talk. I don't know if any of you were on our previous session, but we like to be a little more relaxed. It's maybe some freestyle presentation. Let's just go with the flow. Hello everyone, welcome. My name is Alejandro García. I'm here with Felipe Figueroa, my co-worker. We are both from OpenStack, a company in South America that works, among other things, with OpenStack. I'm product lead there. I've been working at OpenStack like 5.5 years, almost 6. Felipe, you've been working?
I'm working at OpenStack for like 2.5 years. And also I work with OpenStack, and I have contributed to the OpenStack project for services like Neutron or Cinder.
So what we want to just present you today is like a brief of a world story of backups that started like a little more than a year ago. We had to make the disclaimer first that we are talking about the backups from the user perspective itself, not backups from the real cloud. So, for example, we will not discuss things like backing up the MySQL database or the Open vSwitch configurations or whatever. We are just going to be talking about backups for virtual machines. Yes. And we are going to be talking about backups for virtual machines as how our customers see those backups and how they expect those backups to work. Because we were always using the features of backups from OpenStack, but since last year, customers started to migrate from VMware. And in VMware, some things are quite different, and we face like some different scenarios, and that they expected the product to work like more like a VMware stylish, and that's what we face. Specifically, the virtual machines that they started migrated to our OpenStack were quite big. We were talking like they have like gigabytes, hundreds of gigabytes, maybe a terabyte of data in their disks. And we are also talking in like they had different mixed scenarios in which they were using, for instance, just a glance image to root the virtual machine. So the scenarios that we will be discussing here, we won't get much into detail with the glance part, a little more in the Cinder, but I think you may already know this. But just as to mention it, we'll be talking about Cinder, and we'll be talking about the ephemeral disks of the instance. In Cinder, we have volume, block devices, and we will be covering, we'll be talking about mainly made the distinction in the root or the boot device of the virtual machine, that is just the slash path, and other extra volumes that the virtual machine may have. And in the case of Glance, what we also saw that our customers were doing was that they were just booting the virtual machines with Glance images, and they were just storing everything in the boot ephemeral disk, and that was all. So they had like just an instance with the ephemeral disk, and of course the overlay QCOW layer. So we'll be talking and discussing about these scenarios, and the presentation will go more or less in what things we found and how we tackle them. If anyone has a question, want to interrupt at any point, just feel free. It's not passing. So, for the part of Cinder volumes, I believe you all know Cinder and how Cinder works. When we say that we want to back up Cinder volumes, what we have is okay. Basically, when we want to back up Cinder volumes, what we mean is that we have our volumes, our block device disks in what Cinder calls a volume backend. Yes, this backend is basically a storage implementation. In our case, we use Ceph a lot, but we also have allow our customers to have traditional storages like, I don't know, Huawei storage, whatever vendor they use, since Cinder already has a lot of drivers for that. So what we want to do when we say, hey, we want to back up a Cinder volume is that we want to move or transfer the data that is on this volume backend to a logically different, it may be physically the same, but it's a logically different backend, which is called the backup backend, which is, for our case, typically S3 or NFS. There are other drivers for the backup in Cinder, but these two are the ones that we mostly use. And this transfer of data, this copy, so we have the volume here, and we want to back up, so we want to transfer this data to this other backend, is performed by a process or by a service of Cinder, which is called the Cinder backup service, which is different from the main service or the main process that handles this backend, because this backend, remember, it is different than this one. So this could be Ceph or traditional storage, and this could be S3. So the process that knows which driver to use here, it's another different process which is called Cinder volume. I don't know if I'm saying anything new. Yes? It's okay. So how is that flow going to work? Or what is does on the backstage? Basically, we have this Cinder volume and this Cinder backup processes. And what happens? Well, first, when the user executes OpenStack backup create blah blah blah, but obviously it gets translated into an HTTP post to the Cinder API. This creates a record on the SQL database, and then that triggers a let's say a cooperation between Cinder volume and Cinder backup, because Cinder backup knows how to implement the backup backend, because it has a driver for the backup backend. But the volume drive, the Cinder volume is the one that has the volume driver, so the Cinder volume is responsible for handling the volume backend. So what is going to happen is that the Cinder backup is going to request to the Cinder volume, hey, I need to back up this volume, please give it to me. And if the Cinder volume cannot handle that volume, because for instance it is being used, the Cinder volume it's going to handle a temporary copy of such volume. So basically, the Cinder volume will handle to Cinder backup a volume for Cinder backup to perform the copy. So Cinder backup is going to perform the copy from the volume backend to the backup backend. I don't know if this is maybe you understand that? Your rule? Yes. Okay. This is important because here there is a transference of data, because the Cinder backup is going to read from this volume in one storage, and it's going to push the data into different storage. And that's where the problems started to arise.
Can I ask you a question?
Yeah, sure.
Now, this is for the, this only saves the volume, or does it also save the VM's metadata?
Yes, also metadata.
Okay. And for example, if I get an hypervisor that is destroyed before I can, let's say, evacuate a VM, etc., can I restore the full VM backup from this, or do I also need some additional
this is
steps?
just volume backup.
Okay.
You're going to be able to restore the volume,
Okay.
not, for example, I don't know, the networks or whatever the flavor or whatever the virtual machine is using.
Okay, just want to talk to the volume. Thank you.
Okay. So when we do backups, we could have mainly two cases. We could have a full backup case. That is when we don't have a previous backup of a volume, and we need to copy the entire data from the volume backend to the backup backend. But we could also have the case when we need to do an incremental backup. In this case, the logic behind the incremental backup depends on the driver that Cinder-backed is using. In our case, we use drivers that inherit from the chunk driver class from Cinder-backed. That is a class that implements a driver that handles the volume in chunks. Basically, it's parts of the volume, so Cinder-backed can process by chunk and moving the data in one chunk, doing its operations, and moving the data to the backup backend. So when we have an incremental backup, what is happening is that the driver of the Cinder backup service is processing each chunk of the backup, and it's comparing the chunk from the actual volume from the previous backup. So if it's any difference between those chunks, it's going to copy the chunk to the backup backend. In the other case, when the content is the same, it's not going to perform any operation next, because the data is already stored. So this is a way that Cinder-backed handles this case of incremental backups, comparing those chunks, doing a hashing operation on each chunk. So when Cinder-backed receives the volume copy that is necessary for copying the data from one backend to another, it's going to read the volume chunk by chunk, comparing the current chunk with the previous chunk of the original full backup in this case. And if it's the same, it's not going to do the transfer to the backup backend. If it's not, it's going to transfer the data, so the data is stored. As you may notice, it is necessary to have a full backup to an incremental backup logic. So as we say at the start of this presentation, we could also have the case when we want to do a backup of an ephemeral disk. As you may know, Glance does not define the concept of a backup. So to implement the transfer of this ephemeral disk from one store to another, we have to do the following. In Glance, you can do a server snapshot create. What that is going to do is going to take the ephemeral disk of the virtual machine and perform a snapshot that is a temporary copy of the ephemeral disk of the VM. In this case, the ephemeral disk is the base image plus the overlay of that image. With that snapshot, then we can transfer this snapshot that is created from the server from one Glance store to another, replicating in that way the concept of a backup. But remember that Glance does not, the backups do not exist in Glance, but this is a way of implementing that process, replicate that process in the Glance service. So with this flow, we have been able to perform a copy of this ephemeral disk of the virtual machines that we've been migrating from Vim. Well, in the process, we needed to find a way to perform the backup efficiently. So we did have to make some changes and some research on the Cinder backup drivers to find a way to perform a backup in less time. So we observed that backup operations were taking a significant amount, especially because there are two processes or two actions that occurs when the Cinder backup is triggered. In this case, these two operations are the compression of the chunks, because when Cinder moves the chunk from the volume driver to the backup driver, it needs to compress the data. This operation was taking a lot of time, and also there is an operation of hashing that occurs, as I said before, when we have to compare those chunks to do an incremental backup logic. So these two operations were taking a lot of time. In this case, we noticed that the compression operation was using the select algorithm by default, and for the hashing operations, Cinder backup was using MD5 and SH8256 as default for those operations.
I still don't know what is pronounced in English. Do you say SSA, SHA, or SHA?
SHA.
SHA, perfect.
SH8256.
We say that in Spanish too.
So with that insights, we need to find a way to make some changes so we can accelerate the process of a backup. And fortunately, we find that this patch of Cinder adds the support for the newer C-standard algorithm for compression. So this was the easy part. For accelerate the compression process of the backup, we only need to change this configuration in the Cinder-backed.conf file of the Cinder backup service. As you may know, the C-standard algorithm is almost 3 times faster than the select algorithm. So that was a great discovery that we made. We only have to change this configuration. But we also have the other problem that was the hashing operation that was taking also a lot of time, even more than the compression phase. And unfortunately, there was no current way to change this Cinder backup hashing algorithm. So we had to implement it by ourselves. This is part of the patch that we are going to show you later that we contribute to Cinder. But what we have to do here is to add another 2 variables to configure the hashing algorithms used by Cinder backup in the process of hashing. We add this variable called backup chunk hashing algorithm that changed the default MD5 hashing algorithm for a new XX hash algorithm. In this case, the XX hash algorithm is a open source non-cryptographical hashing algorithm developed by Jean Collet. That is the same software developer that develops the standard algorithm. And for the other case of hashing, we replace the default SHA-256 algorithm for the same new hashing algorithm XX hash. Also, this is only the configuration phase. We also have to implement some code to make these changes and allow Cinder backup to switch these algorithms on the fly by changing only the configuration. So, as you may also know, this XX hash algorithm is much faster than the most common hashing algorithms like MD5 or SHA-256. So, when we change those 2 algorithms, the compression and hashing algorithms, we encounter that we observe a backup speed boost from 3 up to 7 times. This means that our several backups were running much faster, and we could do also backups in parallel. So here I'm going to show you, this is a backup of a volume attached to a virtual machine. This is an extra volume of a size of 200 gigabytes. This is the backup before changing the two configuration or the three configuration variables for changing the compression and hashing algorithm. In this case, you can see the Cinder backup logs that we are using MD5 and C-lib for the compression phase. The backup was taking 1 hour, 21 minutes, and 20 seconds to complete. After the change of the three algorithms, we can see that the backup takes only 23 minutes and 1 second. In both cases, this was a full backup of a volume of 200 gigabytes. That was like 3 times faster than the another case. As you can see here, the Cinder backup process is using the XHash algorithm for hashing and the C standard algorithm for compression that are much faster and efficient than the previous one.
We're going fast, like the others. There were also other things that we had to face while deploying and working in our environments. Specifically, some had to do with how we ship our code and our OpenStack releases. We are using Colanzo. I don't know if you know it. For those who don't know, it's a way of deploying OpenStack using Ansible and containers. So basically, we deploy containers directly on the servers, so it's not Kubernetes based, it's just Open Ansible. And that means that some of these configurations, for instance, were not present on Colanzo. It also means that since these containers are built by the Cola project, some things like missing dependencies, etc., were also missed in how these containers were being built. We also had to tackle a lot of things. For instance, okay, this was interesting. This is like a bug on Glance, because as we said before, we were using Glance for snapshots. That was reported like several times. That had to do with how Glance uploads files to the S3 remote backend. And when you have to load like a large file to the S3 backend, what you have to do is you have to slice that file into smaller files, which is why it's called multi-part. And that's how the S3 on the other side knows that, hey, this file I'm not loading you is not the full file, it's just a part, and then I will upload you the next part, etc. So the thing like that is that it was pretty simple. There was a variable size that was not set. So when the Glance was uploading the files to the S3, it was not informing the correct size to the S3, so that multi-part upload failed. So this is something like pretty interesting, that if you try to upload a file that I think was 1 gigabit or 2 gigabits or more like that to S3 with Glance, it just fails. The only thing that you have to do is to add initialization of a variable in the code of Glance. It was reported like several times, and we confirmed with that, and with a one-liner it was fixed. Another thing that we faced on the Glance code is that, as I said, we use mostly Ceph in production, aside from the storages that our customer uses. So we use Ceph to implement the S3. And of course, since that is a deployment in our customers, we use a custom certificate. We don't use a certificate signed by a proper known authority. Well, Glance lacked the ability to specify a custom certificate bundle. So those were not working in those cases. And so fortunately there was already a bug report for that, but it was not merged, so we then tried to use that and it got fixed, so we say like, hey, this truly is a problem and it fixes, and then it got merged. So we had to also port that to our Glance code. And as I was saying, there was a problem with how we deploy Ansible. Basically, Ansible had no support out of the box for the S3 configurations of Glance, so you were not able to specify some S3 variables. So again, it was reported and implemented. And of course, there were more and more issues like keep appearing. Our Cinder, I think only the Cinder images were missing some packages, some dependencies. So we had to detect which were those dependencies, add them to the Docker files, and then ship them again. So again, reported. I think both of those are already merged. We had another problem that we still don't know what actually is. One of our customers had a Huawei storage on their end, and basically the backups were not performing against that specific hardware. We just work around by the command by changing flag in the command, but we still don't know why, because we cannot access the configuration in the remote storage because it's from our customer. We are mostly certain that it has to be with something that they have configured that we don't know. Okay. We have to change a command when doing the backup against the Huawei storage. There was also a deadlock produced by the logging library. It was pretty strange to see in Cinder-backed. This bug was already fixed when we found it, but it was fixed in a newer version than we had in production. Of course, we were not going to upgrade the whole OpenStack for that, so we had to realize which was the bug and backport that to our Cinder-backed containers. It basically was a deadlock, so everything went just they dead out of the loop. And again, missing configurations in Ansible. In Ansible, you can specify some specific files for some storage backends and others, but there was no support for specifying a Huawei backend. So in the Cinder drivers, there are some files that allow you to specify specific things depending on the storage that you're going to use, and the Ansible didn't have support for picking those files and copying them to the Cinder-backed nodes. So again, we had to. I think the blueprint already existed, but we had to implement it. Again, more and more things that just kept happening for months. In the end, it all went well, so we are already performing backups, these kinds of backups in production. We are performing some big ones, which was the thing of the performance that Felipe already said. Like I said, when customers started to migrate from VMware, they were just doing whatever they had on VMware and putting that on OpenStack. So we ended with virtual machines, 600 gigabytes of disk or something like that. Yes?
Can I make a question about the performance part before?
Before the...
about the performance
yes.
of...
performance in terms of time.
Yeah. Have you compared it against bypassing OpenStack for backups and using, for example, directly VSH or QEMU for getting a snapshot of the VM?
We tried doing that, but we wanted to give the user experience by using directly OpenStack. So we wanted that the user could just, hey, I'm going to
Okay.
You know,
And
to
okay.
go inside Horizon,
And
click the
select
backup button and just do that. So that's what we actually wanted to
another
achieve.
question related to this. For example, these changes in Cinder backup, so adding new hashing, etc.
Yes.
Do also reflect in other tools that interact with this. I'm specifically thinking of Freezer, even though that project in this moment is in a strange state.
No, these parts are really actually very self-contained. So we only do that on Cinder and on Glance.
Okay.
And specifically, we are not using Freezer because Freezer also does backup for the database and other things. So we know that it exists, but we are not using that actually to back up the other parts.
Actually, it's in a strange state. It's freezed, but it's not. It's developed, but it's not. So, yeah. Thank you.
More questions? Yes.
So, tested this thing over SAN, and also did you tested it on SAN?
What?
SAN storage agent network, that SAN iSCSI,
Yes.
third-party storage solutions.
Yes.
Like you had just mentioned, like Huawei.
Yes. Those ones are working with SCSI and multipath. Yes.
Okay, multipath. So in that case, means how the CVT works, the change blocks tracking system, the increment. Because you have
Yes.
mentioned two of the issues there, but you haven't mentioned the incremental backup issue, which is there with Huawei. Because you can't take, means the incremental backup with Huawei.
Yes.
That is also an issue is there which we already faced. Other issues are there, but again the incremental issue is also there.
Okay.
It scan overall means from the start. Even if you take the chunks, it will scan it as a LUN, and it will scan it from start to end. Whenever it try to take an incremental backup.
I don't think we have seen that.
I've worked for 1 month for in that part. Yeah.
We may want to check that because that's not a very happy thing.
That's the main reason means most of the what you call this backup solution they are not able to do that. We already worked with two of the backup solution providers for this Huawei iSCSI, and we had a very bad day with the what do you call this CBT. You can say like change block tracking with the incremental backup. It always takes me to the full backup. And then again, means you can't have like 300 VMs you have, and you can't do it in one night. It's like 7 days or like that. It's disaster actually. So that was the third thing. Then you have mentioned.
I may believe that's not happening because they wouldn't have improved because we are doing full and incremental backup. It's a very good thing to know it.
Try to check means
To know and to ask on Monday. That may not be a good thing. I don't know if there are more questions. Yes.
Was it able also to speed up recovery after the backup?
The what, sorry?
If the recovery was also speed up.
The recovery, yes.
Yeah.
Using the same logic but inverse.
And how much?
I don't think we have measured that much, but it was. I would tend to say that it was proportional because we are using the same algorithm.
Okay.
The compression, the same person that used the coded the compression, obviously coded the decompression, so more or less.
Did you also configure the automatic cleanup, taking full backups and deleting all backups?
Yes, we have policy. We have an external agent that actually automates the backup, and we have a policy like let's say something like I don't know, you take a full backup every Sunday, and then you do grandfather backup.
But it's not part of the.
It's not part of OpenStack itself. It's like a bot that's outside. But it only calls OpenStack API.
And then did you experience any performance problem like the machine is inaccessible, becomes really slow?
Not that I recall. as it's not with Ceph. I don't know if use Ceph, but I think with Ceph I can do. Yes?
I just wanted to find out from your data volumes, are you able to list contents of the volumes before restoration in case you need to do partial restore instead of restoring the entire
No, we are not doing partial restore on that way. We're only doing partial restore, like let's say we can restore this specific volume. But we haven't gotten into the part of getting inside the volume but for some backends like NFS or etc., that wouldn't be that hard. That is not. Yes.
You showed that the Cinder-backed uses the two hashing algorithms, MD5 and SHA-256. And SHA-256 is used for the changed chunk detection. Do you know where the MD5 is used for?
There was.
Okay, so we found out that Cinder calculates that hash, but the driver that we're using, that is based on the chunk driver, is not really using that hash. It's a necessary calculation.
It's exactly what we discovered, and that's why we removed it.
Yeah, yes. We found out that the drivers based on the chunk driver, it was not using the MD5.
Yeah, it's just that code.
Yeah, yes. But we don't really delete that line, but it's
we removed it and it's still working.
We thought
that was the solution.
Yeah, so some Cinder volume driver has like storage as instead, let's say volume migration and things like that, where you kind of offload the operation to the storage itself. So does does one of the backend
that is handled by the volume driver itself, I think. So if the volume driver already does it, it will happen.
Right. So is it true for the backup driver as well? Or?
I don't think we're doing it because we are using Ceph. I don't know.
But in Ceph volume, I think like the Ceph volume driver supports like volume migration, which is like storage as well. So I was wondering like something like that exists, like because instead of like computing the chunks in the system, you upload it.
But it's not how the OpenStack implements it when you do a Cinder-backed primitive.
Right.
It actually calls the driver, which actually transforms the copy.
Okay, thank you.
We're being expressed from the